we were left over here. We have to now insert 5 commands for the analysis purpose minimum. We have to do that. So insert file and then include, then browse, then we have to select the default library and the path is my document, tenor EDA, tenor tools v14.1, then LEDIT and LVS, then LVS, then SPR_code, then HP05. This file will be by default file of this tenor EDA. Then you have to go to insert command, and then this insert command here will place the .include file, or if you want to do the latest thing, you can put the .model file in place of including this over here. Now after this inclusion of library file, which is the first thing we have to do, you have to find out the constant. So constant supply is VDD and positive terminal is also VDD, I am naming it. Then negative terminal is GND. DC value will depend upon the technology file, but here I am using by default 3 volt, right? Insert command. So VDD GND3 will come. Sometime after you can keep this thing on notepad and as a ready reference, and you can put whenever it is asked to put these things. After this constant supply has been done, the next thing you have to do to define the input. You can define the input. If it is a digital, you have to use bit, you have to use bus, and you have to use the pulse. These are the 3 things for the digital circuits. Rest are for the things, and constant is definitely for the supply, right? So here the current control, exponential, FM, piecewise linear, sinusoidal, voltage control, this will be used for the analog circuit as a input voltage source. Similarly, if somebody want to give the current source, they can go to this place and they can give over here. After this, you can, now what we are doing, we are having a digital inverter simulation file. So you have to define, we are using the pulse in place of bit and bus. Voltage source name is VDD, sorry, it is whatever is written over here in the net list, that you have to go, you have to type it the same thing. So in negative terminal is GND, initial voltage is 0, maximum value cannot be exceed than the VDD, so that is you have to put it as 3 volt, because we have chosen VDD as 3 volt. Then rise time is 1 nanosecond, fall time is 1 nano. I am taking it by default. Pulse width is suppose 10 nano, and pulse period is 20 nanosecond, right? Corner rounding is the thing which in the later section we can do. Insert command we do, then it will coming as V in, JND, pulse, and so on. After this, these are the 3 things we have done. The 4th thing is the analysis, which is the quite important thing. AC analysis we can do, Fourier analysis, no noise, DC transfer sweep we can find out, DC operating point we can find out through the transfer function analysis, we can find out the transfer function also. But here first we do the transient analysis today, and then maximum time is 1 nanosecond. Simulation time is the thing which is in the user hand, which they can vary, because here it is 20 nanosecond input I have decided as a pulse period, so I will see the 2 cycle of it, so it should be 40 nanosecond. After this I just insert it, and then it is coming .tran 1 and 40n. After it, the last command is the output command. Here you have to go, and then you will see these results. You have to obtain that results which the analysis you have done. So transient results, I am clicking it out. So voltage you can take, current, and so on, but here we are seeing the input and output voltage. So in then GND over here you have to type, add it here, you have to do OUT, then GND, and so on. You have to take it, add, Then after this, again insert it. Then what else? Dot include vdd vin dot run dot print. So we have finished all the things except the extra thing which we can do, that is the optimization part. In place of that, it will be easier for me to go to dot power and write it vdd to do the power analysis of it, right? Today we do the power analysis, next turn on we can do the other things. Here the most important thing is to analyze something, you have to save it at a particular place so that it will come dot out file. Dot out file will come over here, which will give us the things. So I'm saving it out in academics, my drive, D drive, and then I had to search it out. BTech. What was it? I started with BTech or? Yeah, this is. I got it. Then ER13, and then you have to place it with that, right? So it's okay. Now after this, we have to run this. So there are three ways to run. First is this symbol, right? Green triangle symbol, you can run it. Second is you can go to simulation tab and then you can run simulation. And third is the F5. Whichever is convenient to anybody, they can follow that thing. After this, the WEdit will open and the waveform will come. If it is some errors are there, it will generate over here, and then you can eradicate that thing. So here it is coming that inverter.sp line 28 variable 0 not defined, cannot evaluate initial value for the source, and just okay, yeah, this is here it is coming, and anything else just simulate it again, and then so waveform is coming. So it's taking time. So here, from here you can expand it, right? So exactly you can see it is inverting the thing. This is here in, this is here out, and 3.3 voltage we have given as a input. So it is coming as 3 volt. Okay? Now if I want to use this inverter design, what I can do, I can just take it this as a, now before that we have done the power analysis, so we must see power analysis. So we will go to our folder, that is the academics folder, and then we will see the BTech EC, and then ER13. Then dot out file will be generated. Where is it? Spice Netflix is there. INV Spice simulation is there. You have to open this with the notepad. So see, this is the dot out file, and here these are the points through which it is plotting in the WEdit, time in and out, right? And here transient analysis is given, right? 1 nanosecond to 40 nanoseconds. So 40 nano will be 4 into 10 to the power minus 8, right? As well as here the power analysis will come. So here it is from 0 to 40 nanosecond. It is consuming an average power of 1.31147 into 10 is power minus 5, which is approximately 13.11 microwatts, right? Similarly, we can put here the dot measure command is there, from which you can measure it, the delay time. Automatically it will come in the this PSpice simulation file, which is, I call it as a dot output file, right? Now we have to go back to as edit, and then we have to generate the buffer. Now I have to take this fast so that it will be not go again into. So Control C, I am taking this as a PSpice because I need that thing. Then I go to the as edit. So as edit is already open. So now what I will do, I will take this as a symbol. So how to do it? That cell and generate symbol. It will replace it through a symbol. I will click this and I will delete these things, and I generate my own symbol through this path and right angle, all angle button. I will click it, and then I will generate myself the symbol, and here I need a circle. So then again pick this thing, alter, and through this button I can drag it over here something. It is taking some time. Okay, sorry for this. I'm making this as a small so that I can have a larger thing. If it is, then it is not occupying the large size. So by this label, I will put the label as caps on INV, then down is there. Okay, so okay, and if it is not coming appropriate, so we can change it from here. The font size, it will be around 12. So that will be, and x-axis and y-axis is there. So 1 is there, so above is there, so 0.6 will be there. Okay, so it is coming outside, so 11 will be better. No, 10 will be better, or rather 9 I can do. So that's x-axis 1.01, so 0.8 is will be there. So that's okay. So now this I will, now again this is a symbol which is not saved, so we have to always save first. Then what we will do, we have to reuse this. So new view, cell 0, in place of this I will write buffer. Symbol we are not generating, so we go to schematic and then okay it. Then zoom, for zooming you have to create zoom minus button. Then you go to your library, ER13 is my library, so INV, I have generated that thing. So that's 2 in cascade I'm using, so that is input and output you have to connect. So that's the input, and that's the buffer design will be completed. So this will be the PSpice, you have to open it. To this I have already taken the Control C the things which I have to paste it over here. So this is the inverter file, I have to close it. This is the buffer file, PSpice file, so I have to Control V this thing, and then I have to check cautiously that input and output are in the same manner. Out is there, in is there, out is there, in is there. Okay, so all things are set. Now we have to simulate it. By simulation, it will first automatically save it and then it will simulate it.